Aloha Kako. In this video, we're going to be talking about generic classes with type bounds. Up until now, we've been talking about generic methods with type bounds. We did generic classes in our last video. In this video, we're going to do the natural progression here. We're going to talk about generic classes with type bounds. So let me go ahead and share my screen with you. So we're going to be talking about what happens when we're using unbounded type parameters. When we compile, the Java compiler is going to basically use type erasure to replace all the unbounded type parameters with the object type. So for example, the Java compiler changes the class field declared as coordinate type X to object X. So if coordinate type is a class type parameter without a type bound, in instance of an unbounded type parameter, it's only going to support the methods and the operations that are valid for that object class. So we talked about this before when we were talking about generic methods with type bounds. It's the same here in classes. So we're going to look at this participation activity here. And in the participation activity, go ahead and start. You'll see that we're dealing over here with class point. Class point has coordinate type. You see all the different places that we're using coordinate type. We're using it in the definition of the attributes. We've got here in our constructor, we're using it for the arguments. And then over here, you'll see what happens when we've done the type erasure. When we've done the type erasure, we've taken all these coordinate type references and changed them to object. So so over here, you'll get your explanation. The Java compiler internally replaces uses of the point class's unbounded type parameter with the object type. So we'll go on to the next part. Next part, a program calls a constructor the type erased point class to create a point double object. Double inherits from object, so the XY, the XVal and the YVal arguments are implicitly converted to object references. So, yep. So that's what you have going on right here. Then type erasure changes the types of fields X and Y to object. So X and Y only support the methods defined by the object class, like toString. And runtime polymorphism ensures that the X.toString calls on doubles toString. And in our last step here, we look at that, and the point class's toString method returns a string representation of the X and Y coordinates. So this is as we expected. We talked about this earlier when we were talking about the type erasure in methods. Now we're going to look at some of our participation activities based on this. So for a generic point class with an unbounded type parameter, so using the example above, we're going to look at the questions here. What is the correct type for the arguments xval and yval in the statement below? So over here, we've got point integer, point equals new point of integer xval and yval. So what are the correct type for these arguments here? So the correct type, if we go up there and we look at it, we're going to be looking at over here. So in our constructor for point, we have coordinate type. So if our coordinate type is integer, it should be integer. And that's correct. So the statement below passes literal values to the point class's constructor. Does the statement below compile? So you got point of integer, point equals new point of integer 1 and 2. So that should, so autoboxing automatically converts literals 1 and 2 to object of type integer. So the integer arguments are then automatically converted to object references when passed the constructor of type erased point class. So the statement compiles. Which type arguments are valid in the statement below? So point, what of point? So what type arguments are valid here? So for this one, because we're talking about unbound, it should be all class types. If it was, let's say, number, then you could say the double and string, or double and integer, but not string. So but over here, type bound is needed to restrict the type parameter. So there's no restrictions on this one. What is the type of the X and Y fields after type erasure for an object of type point integer? So the X and Y fields, let's go up and look at our code again. X and Y, they're receiving the values from here. which are based on the coordinate type. So whatever the coordinate type comes out to. So if it's integer, then, it actually, so what is the type of the X and Y fields after type erasure? So after, oh, yeah, it's object because we've set it to object. So this is going to be replaced with object over here. So your internals, when you look at it, it's going to be set to this. Okay. So then we go to which methods can be called on fields X and Y for an object of type point of integer. So is it going to be all methods defined by the object class, all methods defined by the integer class, all methods defined by the number class? So as we saw before, we're talking about an unbounded here. So we're looking at all methods defined by the object class. And you can go and click on the different ones and try to get more information out of them as well. So after type erasure, what is the type of the xval parameter in the below set x method definition? So if we look at here, we see the set x, and we're looking to find the type for the xval. So what type is it going to be for the xval? So hold on, we're using coordinate type up here for x and y. So we're setting x to this. We're going to have it as the object type. So remember, Java's type erasure replaces unbounded type parameters like coordinate type, which we see up here, with the object type. So that'd be object type. So that is that. So because of that, the types have to match here. So this is, the object type. So we have to have xval, match that. So after type erasure, what is the return type of the below getX method definition? So we're going to take a look at this public class coordinate OK, private coordinate type X, coordinate type Y, public what getX return X. So we're going to return we're going to return X. So it's going to have to be of the same type as X. That's going to be coordinate type. So what would that be? It's not going to be coordinate type because, as we stated earlier, the erasure is going to replace that with object. So it's unbound, so it's going to be object. Yep. Here we go. So moving on, we've talked about the unbound type erasure. Now we're going to talk about what happens when you've got bound type parameters. So a programmer may want to restrict the kinds of type arguments that can be used for a generic class's type parameter. For example, the generic point class that only uses numerical coordinate types. This is exactly what we saw earlier when we talked about methods, using bound type parameters in methods. So type bound restricts the types that can be used as type arguments for a type parameter. So for example, coordinate type, you can say coordinate type extends number, and that specifies that a type argument for the coordinate type parameter must be a number or a subclass of the number class. So Java's type erasure replaces all of these unbounded type, or all these bounded type parameters with the type bound. So if it were using number, it would instead of moving it to object like for unbound, it would convert that to number. So an instance of a bounded type parameter can access the class member methods of the class specified by the type bound. So in this case, it would be number. So we're going to look at our participation activity here. We'll start out. The Java compiler replaces uses of the points class type parameter with the number type bound. So you see all here the highlighted areas where it's coordinate type. It's going to be replacing that with number. And then the program calls a constructor of the type erase point class to create a point integer object. Integer inherits from number. So the xval and yval arguments are implicitly converted to number references. Then the x and y fields are of type number, which defines the double value method. The integer class overrides the double value method to return a double from an integer. And the final step, the point class's distance to origin method returns point distance to the point to the origin point 0, 0. So this is pretty straightforward. This is just like it was when we were discussing the bounded type parameters for generic methods. So we get into some more questions. Consider the above generic point class with a number type bound. Which type arguments are valid in the statement below? Point, what of point? So we know that, point with number type bound, we know that it's going to be number and subclasses of number. So that was discussed above. What is the type of the X and Y fields after type erasure for an object of type point double? So let's look at what our X and Y are up there. So X and Y are going to be the specified ones, so that would be double. After type erasure though, it'll be number because it's not double anymore. It's number because we're doing a type bound here. So which methods can be called on fields X and Y for an object of type point double? So let's see, methods. Oh, so if we're doing point double, then it's only going to be methods defined by the number class because after erasure, we've of course replaced it with number class. So there we go. Complete the below get X as double method to return the X as a field as a double. So when we look at this, let's see. So get X as double method to return the X field. So X is a coordinate type. That's going to be replaced, or it's going to be erased to number. So we're going to need to return what here? So when you look at the three choices here, we're not going to be returning, it's going to be number. So what is defined as number? So double value of is not it. X alone would not do it. It's got to be X because double value is defined as a method of number. Yeah. So now we're given a route distance calculator. You can look through the code here. It looks like there's two files. There's the point.java file that gives you the point class. So when we look at point class, it takes a coordinate type. We're type bounding it with number. So we're saying coordinate type extends number. We've got private coordinate type X and Y. So those are our internal fields there. Then we've got the constructor. It's taking in two different values here that are coordinate type. Okay, then we've got coordinate type. We've got get X, get Y. Then we've got set X and set Y. Okay, that's regular. Then we've got our toString defined here. Then we've got a distance to, which is using that same point type thing here. Okay, so route distance looks like we've got, so we look at this, we set up a scanner, setting up the route distance, the total number of points, the point index. We're setting up a point double of first point and also last point here. Then we're making an array of it, doing a lot of different things here. So let's go down into our participation activities to see what's going on. So after type erasure, what is the return type of the point class's getX method? So getX, if we look back up there at our, if we look at our class there, we see that coordinate type extends number, so it's going to be erased to number. And after type erasure, what is the type of the Y value parameter in the point class's set Y? So if we look at set Y is over here. What is the value of, let's see the question again. What is the type of Y value parameter? So if we look up there at Y value parameter, it's coordinate type, but coordinate type gets erased to number here. So it's number. What are valid type arguments for the endpoint variation or variable declaration below? So let's look at this. So point double start point equals new double point. Okay, that's fine. Point of what? For endpoint equals that. Then we've got double distance equals start point dot distance to endpoint. So okay, so we're going to be doing things that are comparable here. So they're going to have the same types. So that's going to be point of double here. So this would need to be double. Yep. So the distance to methods arguments must have the same type as the star point object. So endpoint must also have the type point double. So that makes sense. And the last thing we're going to do is a challenge activity here. So we're going to be putting in our code. So I'll let you do this. This is just going to test your knowledge of syntax for doing this. So if we look here, I'll do the first one out of the three. So let's take a look at it. So complete the definition of the generic class as follows. Let's go ahead and hit start to begin with. So the access modifier is public. So you look here, we're going to be creating the class. So we're going to go ahead here and say public class, and then we know that the access monitor, okay, the access monitor is public. The class name is blood pressure range. And the type parameter, blood pressure type, has a number bound. Okay, yeah. So it's telling us some important information here, and that is that blood pressure's type, and that is extending number. So I believe that is the correct syntax. So we hit check. And that's correct. So as you go through here, it's going to be asking you to do similar things. So the first one, we define the class. This one, we're going to go in here, and it looks like we're going to be building the constructor. Maybe the next one is doing a method. So just go ahead and follow these piece by, follow the instructions, and set up your syntax. This is really just testing your syntax and your knowledge of how it's supposed to look. So that's all. This is generic classes with type bounds. If it seems like deja vu, that's because it was pretty much the same thing in generic methods with type bounds. The same concepts apply. If you have any questions about this, if it doesn't make any sense to you, reach out to me. I'd be happy to help you. Until the next video, take care, and I'll see you then. Bye-bye.